This conference will now be recorded.
Okay, hi folks. This is a presentation by myself, Mark Schildhauer, David Smith, and Brandon Whitehead. We're going to be talking about semantic models of soil bulk density, wherefore and how. And the breakdown of our talk will be basically like this. First of all, I'll give a little rationale for the semantic approach, talk a bit about why we chose soil bulk density, then hand it off to Dave, who'll review some of the bulk density methods and talk about some of the commonalities he found in his research. Come back to me, I'll talk about some work my group has done building and using ontologies in general, soil ontology in particular. Brandon is going to take us into a much deeper dive into modeling of soil ontologies, and hopefully we'll have a little time reserved at the end for Q&A. So what is the rationale for a semantic approach? And you can see that wise little screen at the bottom is to make it so that both human and machines are able to effectively work with resources on the web. So, we start out with the fact that there's lots of soil data out there, and I've listed here, I think, some of the major data resources that many of you are familiar with, but then the little dots represent all these independent soil researchers doing their own work in their own way all over the world. So the issue here really is you know how to find and you know how to use your favorite data resources. You know that website, you know it back and forth, or you've downloaded all the resources, you got them tidily arranged to interoperate with your, RStudio or Jupyter notebooks or whatever. But really, a lot of times you need more data. You need it to do synthesis, which means that you're trying to broaden or generalize your studies on soil. Sometimes you might want to validate or replicate your own work or others, so you need to find other data that might be of a similar type or in a similar region. And then also a lot of times we are looking for complementary data that can enrich our understanding of what's going on even in a specific area. So how are you going to find and access those types of additional data that you don't know about? Well, the problems, of course, are that those data are distributed all around the internet. They are housed in different types of websites with very, very different types of user interfaces that you've got to, navigate and drill down to finally get to the goods. When you finally find the data of potential interest, you find that they're in really heterogeneous formats. And also the schemas, the underlying data models are quite variable. And even at the level of when you're looking at the data, like you open a spreadsheet, you're looking at the column labels, you see all sorts of idiosyncratic naming of features, and then the measurements themselves might be taken using quite different methods. So, it wouldn't be a wonderful world if you could say, well, I want to know databases that contain these parameters X, Y, and Z. And then when you find two data sets that allegedly have parameter X, you are comfortable knowing that you can actually just integrate those two data sets. Then you're kind of, like, well, exactly what methodology was used in collecting these parameters or measurements? What was the spatial resolution at which these measurements pertain? What regions were sampled throughout this data set? Do I have the most recent versions of this data set, or did I manage to find something that's quite old and stale? And we want to answer these common queries, ideally via the web. So that gets us to where we are. Why did we choose soil bulk density? Well, I've worked a lot with some of these environmental data repositories, most notably and recently DataONE and the Arctic Data Center. And we've found that researchers are usually, when they're looking for data, it's data that contains specific types of measurements. And in this context, it would be specific types of soil measurements. And a couple of meetings ago, we all agreed that soil bulk density is an important measurement, you know, almost ubiquitously important to soil researchers. There were several other prospects that emerged as well: KSAT, porosity, soil organic carbon, etc. But we said, okay, well, let's just start, you know, and get a handle on what the issue is with soil bulk density. We knew we'd have to deal with a lot of methodological variation. One of our colleagues, Andrew from Australia, really made that quite pointedly. So we decided maybe this is an ideal seed measurement for starting to build the ontology. So this is the handoff to Dave, who's going to take us through a little bit of his research into bulk density methods. Dave?
Okay, Mark, thanks. Can everybody hear me? Can somebody give me a thumbs up? You hear me? Okay, good.
Yep.
Do you need presenter?
No, Mark, if you can just turn slides for me, that would be great. So, you know, my part here, you can stay on that first slide, or it's fine, leave it here. But my part here is really going to be to sort of provide a foundational summary about bulk density data, which I hope will set the stage for expanding to, you know, more progressively detailed specific conversations that Mark and Brandon will follow up with, and that'll happen in the discussion. I'm not really clear within the ESP cluster if we're all soil scientists, or if there's, you know, I think there's some knowledge engineers and soil scientists. So, you know, I hope my review is basic, and I hope it'll be useful to both groups in helping sort of put some structure to the conversation. Okay, next slide. So I'm sort of a simple, basic person. The way I started in a review is sort of trying to compile, where do I go look? And so I've put together some documents which I've put up on the Google Drive, which the intent is that I hope it helps everybody. I mean, I've kind of done some homework and put some things together that maybe will be useful to others. But first place I looked is where are the authoritative sources that we should start looking for, where databases are, how things are defined, where the procedures manuals are. And of course, I went to where I'm most familiar with, you know, National Cooperative Soil Survey in the U.S. through NRCS. Looked at, you know, FAO, ISRIC, CSIRO, the GRC in the EU, kind of went online and found all those sources. So that, and this is, I want to stress, only a partial list. This is no way intended to be complete, but these are just things I looked at in the last week. So next slide, please. Now, this slide is not intended to be read, so don't try to read it, but it's just an example of what I've compiled in documents, which again, my hope is this is useful to somebody. And what I've done is, you know, I just did a bunch of searches and did my own homework, and I was, you know, sort of trying to array things in a matrix to see things, how definitions or procedures compare with each other. And what I did is just linked all those web sources to the authoritative sources in a document. And again, I think there's about 3 or 4 documents I put on the Google Drive, which are there now, and hopefully will be useful to people. So this is an example. What are the listings of all the procedure manuals with FAO, NRCS, CISRO, et cetera? Next slide. So just as an example of some of the comparisons I started to do at a very basic level of how do we define bulk density, by and large, the 5 sources that I put up on the screen here are just a sampling of what I found, and they're all pretty much generally the same. However, they're not. I mean, this is just the lead sentence in each of the places where bulk density, soil bulk density is described here. And you see, you know, the ratio of mass of solids to the total bulk volume. Yeah, I think we all agree. The Soil Science Society of America adds we're talking about dry soil. NRCS's lead-in sentence doesn't say that. The ISRIC's WOSIS manual, you know, specifies oven dry, which is how we often think about it. FAO actually defines oven dry at 105 Celsius. And then, you know, and NASA has a definition that they just go back to dry. Now, each of these definitions in the sources where I found them then drill down deeper in following sentences and even paragraphs. Of course, we as soil scientists know that we need to understand something about the soil water state of when the sample was measured, and are we talking fine fraction, our whole soil, et cetera. point I'm trying to make here is even at the very basic level of the broad definition, there is a little bit of harmonizing opportunity. Next slide. So, and this one is again hard to read, and this is one of the things that's up on the Google Drive, and I'm not done here, but I started to try to array things in a matrix looking at laboratory methods. And I started with the Kellogg Soil Survey Methods Manual. And, you know, again, the soil scientists will be familiar that there's a number of different water states in which we measure bulk density, and there's a number of different methods: compliant cavities, saran, you know, core, dipping them in saran, clods, etc. And so when we go to a database, you know, we have to distinguish what kind of measurement is being made. And so the methods manual, the KSSL methods manual is a very good reference, really lays this all out in detail, and it's, you know, 45 pages or so worth of technical description. I then started to do some cross-referencing and comparison to, you know, the ISRIC procedures manual, to a best practice manual that the UN FAO is putting together, and so forth and so on. I didn't get very far in that, but you know, the X's are showing where there is some commonality, but there's, you know, there's more work to do here to do some cross comparison to these procedures, commonality procedures.
David, at risk of interrupting you, are these methods interrelated in the NRCS manual, or is that something that we would have to infer from reading them themselves, or is it listed out hierarchically in a way that we could capture?
It's listed out hierarchically, and I'm not sure what you mean by interrelated. But I think it's very well organized and very, you know, it's a very good authoritative reference for each of these procedures. And it talks about how each of these procedures are used, talks about considerations for the procedures. Doug Wasaki is online here as a, you know, retired director of the Soil Survey Laboratory, and be glad to defer to him, and Doug, if you want to kick anything in. Go ahead to the next slide, just in the sake of time, Mark. And Doug, you know, please you know, contribute to the discussion if appropriate. I wanted to make this point too. Bulk density, you know, to me is both a simple thing, but you know, it's really gets pretty complex when you start thinking about it and organizing it. Very simply, you know, mass per unit volume. We as soil scientists recognize, you know, that soil bulk density includes both the solids and the pore space, and that, you know, it's a function rather really than a single value. It's necessary, as have already been said, that we need to know and designate the soil water state of the sample when the volume was measured. Are we talking fine earth fraction that we're dealing with, or the whole soil basis, etc. So point being is bulk density is measured under varying conditions using varying methods. Next slide. And, you know, this just displays what we're talking about. I can't point with my mouse, but on the left side, you know, these are KSSL methods, just a listing of the current methodologies that are used and measures that are found in databases. And of course, when people are querying the data, they're doing this because they use these various measurements for calculating things like carbon stocks and, you know, linear extensibility, water retention, converting data from weight to basis to volume, estimating, you know, where compacted layers, etc. So we have reasons for wanting to query these data. And the point I'm trying to make is there's basic thing is still bulk density, but there's all these different measures, and how is that going to be arrayed in the database, and how do you find it? Next slide. So yeah, just please proceed. So, and this is just my way of thinking, and I think this ties into the ontology discussions. If we take a hierarchical approach to thinking about this, it's going to help us organize ourselves. So an example that's in an ontology that's out there that I found is the AgriVoc through the FAO. When I searched for bulk density, I didn't find bulk density, but I found soil density. And, you know, if you go up the hierarchy, it nests underneath the concept of properties. Underneath properties, there are 35 subconcepts of what a property is. And one of those subconcepts is soil properties. And then I drilled down to 12 concepts underneath soil properties, and soil chemical physical properties is one of those. And that's where I found density. And that got me to thinking about going back to our KSSL list of bulk density methods. Couldn't we just do the same thing I mean, if we started conceptually with an ontology that defines soil, went down to soil properties, physical properties, found bulk density there, and then we could start drilling down into the different sort of water states that we'd measure bulk density under, what kind of methods we were using to get there. And my last slide will just expands on that a little bit in a little bit more detail. So I just offer this. This is not anywhere. This is just something I drew up, but this is just a way of starting to organize how we would think about tabulating our bulk density measurements, putting them into a controlled vocabulary or an ontology, and, you know, be able to search for these kinds of data in a database and link back to where they're defined and very, you know, specifically. So that's where I end.
Great, thanks, Dave. So that was just a great prelude to thinking about how semantics might help to address some of those issues that Dave was encountering head on as he's trying to kind of clarify all of these different methodological manifestations of soil bulk density. So I'm going to try to hammer home some of the advantages that semantics can provide to solve some of those issues. And this is a real landmark paper that came out in late 2016, and it's the FAIR principles. Some of you potentially have heard about them. The FAIR is an acronym standing for findable, accessible, interoperable, reusable. It was, you know, this paper by Wilkinson et al., and you can see it's principles for scientific data management and stewardship. And it's really about this idea of like, how do we make data more findable, accessible, interoperable, reusable? And we can say, well, what's so difficult about that? And the problem, we've already alluded to it, is the data are distributed. They're highly heterogeneous. There's lots of data out there. So really being able to sift through and find the data that you're interested, the data you need, it's not trivial. And then finally, the way that data are described has what they call lexical ambiguity. I mean, when you think about it, we describe the contents of data using, you know, our preferred language. Let's say, for the most part on this call, it might be English. And so we use these words, which are just strings. They don't have necessarily a deeper, they have an implied meaning. We also all know from grade school about things called synonyms and homonyms. And we know that terms also can be arranged in hierarchies. And Dave was showing some of the natural hierarchies that he was seeing in these descriptions of bulk density. And then you also have this notion of relationships, which is how something is related to another thing, like, for instance, how hydraulic conductivity might be related to bulk density. These are the challenges. But luckily, there are some semantic low-hanging fruit. So it was funny, the other day, Dave and I were talking, and he was reassuring me that capital D, little b, that means bulk density. But then when I was exploring around, I found out, well, in Australia, it's capital B, capital D. That's what they call bulk density over there. So you show a soil researcher, and immediately they understand soil bulk density in the context of USA or Australia. And the fact is, those are both, you know, indicators of soil bulk density. And even the word soil, you know, which to a soil scientist thinking about Earth soil, it's probably some sort of, you know, organic carbon component to it. But, you know, soil is also used in the broader context, like the lunar soil. That's a clipping from a headline in the New York Times there. And then finally, hierarchy, where you've got this DB subscripted 0.33, and we can use ontologies to very, very formally say that this is a subclass. That, in other words, it's a type of soil bulk density. Take a completely cryptic, maybe not to an American soil scientist, but to an Australian one or a Chinese one, and tie it to a term with which they are familiar. Ontologies then are formal representations that can disambiguate these types of terms, and they're interpretable in a very consistent way by machines and hopefully humans as well. So here's a glimpse of a well-known formal ontology called ENVO, or the environment ontology. The view that you're seeing there is using a ontology editor known as Protege. So this is just a visualization, kind of a framing, if you will. This is not just like a PDF. This is actually an application that's interpreting the very formal language, the knowledge representation language that's underneath ENVO. It's what ENVO is authored in. And you can see, first of all, there's this term cryosol right here. And the first thing to note is that it has a permanent dereferenceable identifier. And that you can see right over here. If you take this HTTP URI and plug it into your web browser, you will learn what cryosol is. This is a view, again, of using an application called Protege of what cryosol is in the environment ontology, where we've defined it. Now, this term definition, that's also a very standard structure in ontologies about how you specify this is the slot where you find the definition of the term. You can see that's got a related synonym. We also provide a cross-reference to where we got that definition. This is all a way of enriching what would simply be a naked term, cryosol, which many of you might be familiar with, but you can imagine terms like soil, whether you're talking about lunar soil or only earth soil. So the semantics to make soil data fairer that you just saw there with that view of an ontology using this Protege software is that you use web-based persistent identifiers associated with each term. The ontology itself is created using open protocols, so it can be expressed in something like XML, or this is a special knowledge representation format called Turtle, or some of you may know JSON, or really even CSV. It's interoperable because it's based on open community standards, like some of you may have heard of schema.org, which is endorsed by all the major web search engines like Google or Microsoft's Bing, JSON LD, or most importantly here, there are these two worldwide web consortium standards for how you create these ontologies in the languages called RDF and OWL. OWL stands actually for Web Ontology Language. And this also makes them reusable because if you have an OWL ontology, or it could be using schema.org terms, the semantics are defined just in that same way that that earlier slide showed you how we had defined cryosol. So here's a view of an ontology that I've been working a lot on. I think I saw Margaret O'Brien. She's a colleague who's also worked a lot on EXO, the ecosystems ontology. Here again, you can see that we have a dereferenceable, unique, and persistent identifier. If you plug that into the web, you will see something like this. It'll tell you exactly what this EXO 00003084 is. It's a stomatical conductance. But again, using Protege, we can see that stomatal conductance is actually a type of carbon dioxide flux, which is actually a type of carbon flux. So if you're looking for measurements, say, of carbon flux, you will find the measurements of stomatic conductance. Now, this view over here is really useful because there are these things called ontology repositories. So they can take ontologies written in RDF and OWL and provide nice standardized views of them. And ESIP has one they call the core, which stands for the Community Ontology Repository. There are several of those. There's one called BioPortal, they're Ontopy. What they all do is they can parse that RDF and OWL script and provide nice human readable visualizations of the ontology. And of course, machines, given that these are very formally structured, can parse them and do all sorts of stuff under the hood as well. So there in this slide, we've got the interoperability and the accessible. Now, how do you deal with making those connect with the data? And so this is how we're doing it on DataONE, which is a big metadata aggregator. The raw data sets can be in CSV or other formats. Down here at the bottom, we've got representations here of two different tables of data, and you can see their column headers are quite different. And then in DataONE, we describe all those data sets in a metadata language called EML, which is basically an XML style metadata language. I think the LTER community also uses EML in their EDI, environmental data repository. We then optionally can pull these, we can describe the metadata. So here now we're semantically describing the metadata. It can go through an observational model. Some of you may have heard of one called SOSA or SSN. We have one called Oboe. And then ultimately you get up here to the web-based domain ontologies. This is where I'm showing here EXO, the EXO ontology. This is where you'd have your soil ontology. And you would be linking columns in your raw data down here at the bottom to topics in your domain ontology. In this case, I have here, this is an example from vegetation ecology, but instead of leaf litter, we would be talking about soil bulk density measurements. So we covered the I and the A in that earlier slide. We showed how semantic annotation binds that information to your data. This is a view of how we're enabling that in our Arctic Data Center repository. You can see here we have annotations. Those annotations represent that linking of that metadata construct to a term in an ontology. Now, when you search in the Arctic Data Center right here, like searching for carbon dioxide flux, you get this drop-down list. These are all terms from our ontology, from the EXO ontology. So these are flattening hierarchies and showing you where this notion of carbon dioxide flux has occurred somewhere in the ontology. You can then drill down and make your search query more precise. Now, there is a soil bulk density measurement in the EXO ontology, and here it is. This is a picture of it. Again, this is using an application called Protege, soil bulk density, and here you can see we've got a label for it. Here, this is the creator. I don't know who this might be. This might be Margaret. There's the definition, or Stephen Chong, who was a postdoc working on this knowledge model. This is the definition of it. It shows what our definition source was, an example of usage. There's a whole bunch of really standard, all these things in blue, they're very standard defined fields that you can fill in an ontology. And again, importantly, if you took this HTTP URI right up here and you pop that in a web browser, you would be able to understand what this is, because we've pushed this EXO ontology into an ontology repository. Now, if you did that search for soil bulk density in the Arctic Data Center, you'd come up with, I think, 3 or 4 data sets, and here are representations of the value of that semantic annotation on a data set. And you can see here on the left here, we've got, these are the various columns or attributes of this table called this. And you can see this table actually had a column which was nicely called bulk density. So it was a little bit a giveaway, but this annotation is showing, oh, this is actually a soil bulk density, not just because actually bulk density is a generalized term of, mass per volume. And it shows what our definition of soil bulk density is, and it gives you a link to that dereferenceable URL to go to the ontology, where you can also learn more about what soil bulk density is. Over here in this table, they had called bulk density just this one word, bulk density. So a more striking example would be if these two terms were different. Like I think in Sergo, one of the bulk density measurements might be something like 10th bar dB underscore J or L or something like that. It's a lot more cryptic. But clearly, if you'd annotate it to this notion of soil bulk density, it would be much clearer. So the semantic enhancements that we can make soil data fairer include creating these ontologies, making the annotations that link terms in the ontologies to the data structures, and then of course you have to provide scripts and user interfaces to enable researchers to interact or create those annotations. Tim Berners-Lee was the inventor of the web, and this is all part. This approach we're describing here with RDF and OWL and dereferenceable HTTP URIs, it's all part of the semantic web. And what the founder of the web, the inventor of the web, Tim Berners-Lee says is you should use URIs to name things, and that's what we've done. Those should be HTTP URIs so that you can dereference them and look them up. And when someone looks up a URI, there's useful information there. And you include links to other URIs so they can discover more things. So this is the framework of the semantic web. It's also how, if you heard about it, this notion of linked open data works. So that was like a brief view into how this formal semantic approach could really be useful, why soil ontology, this exercise in building a soil ontology can be, very useful. And now Brandon is going to dive deeper into the ontology modeling of soil.
Yeah, Mark, in the interest of time, do you mind if we just continue? And then at the end, I'll take over if we need to.
Okay, sounds good.
Okay, thanks. Yeah, so I just wanted to actually, after that last meeting where a few meetings ago, where we were looking at deciding to model bulk density or figure out what the definitions are and the methods and so forth. I, with a background in earth science, I didn't really feel that I had a good knowledge base to proceed and I wasn't sure what I had to contribute. So I thought, well, I'll look at some of the databases that we talked about and see what's in there and see, like from that perspective, what might we model it? So the opposite end from what Dave was talking about, right? Earlier in the slides. So in earlier discussions, we had talked about ISRAD, WOSIS, which I also have a little bit of experience with, and then Will Weeder mentioned, I think he did a presentation on SODA, and I thought I'd just have a look at these three first, right? So the first one was actually WOSIS, excuse the misorder. So this is just from this link, and I was looking at what they had for bulk density, what their definitions were, in an attempt to try to deconstruct. Oh, sorry, Mark, can you go to the next slide? Thanks. And the next one. And just as yeah, thanks. Just as a way to figure out what kind of descriptions they'd had. And so I noticed they have the codes, the property names. Great, they have units and then a description. Next slide, please. So I thought, well, I'll just try and see if I can put that into this is a concept mapping tool called CMap that I like to use because there's no there's no real restrictions. You can just kind of put whatever you want in there. So I thought, all right, well, I'll try and sort of transfer this over. So I put the first one in, thinking that, so we have on the right side, I sort of brought in the description and I labeled it with the SCO's definition predicate. All right, now that could be several different predicates. I'm just, this is me sort of thinking out loud, if you will. All right. And then the middle concept is I kept the code name, and then I use a sort of a hack for a naming convention for the namespace, excuse me. So WOSIS, so that I can kind of know, since I wanted to see if I could model different databases, I wanted to know where things came from. All right, so I'm just using that as a hacky namespace deal. And I'm saying that it's a type of the bulk density, excuse me, fine earth, right? And this is the equilibrated version. All right, so next slide, please. And then I just did that for everything on that table. Okay, I just brought them in to see if I could try and match them, line them up. So next slide, please. So the first, I don't know how much experience you all have with this, but after looking through a bit, I realized that, all right, so we've got a couple different facets. There's fine earth versus whole soil. And then they have different, if it was air dried or field moisture, oven dry, that type of thing. But they're repetitive. All right. So if you go to the next slide, Mark, please, and the next one. Yeah, thanks. So I really wanted to just highlight this area and see what I could pick apart. And so obviously we have the notion of whole soil and fine earth. This time I put the comments as RDF comment, which is just a different way to capture natural language text in your model. And it's not really restricted to anything, but so for context, I wanted to know what this was. And I also added the part of relation. So I wanted to make sure that we know that, at least my current understanding was that fine earth is a part of whole soil, and that's always true. Okay. Now, before you all raise your hands and tell me about the qualifiers, this is just me, again, this is sort of me thinking out loud. All right. One more slide, please. And then I also thought, okay, we're going to need, at some point, I need to connect this up to bulk density, like the concept of bulk density, since that's what we're interested in. And hopefully these will line up somehow. So I pulled in what was in the other, on the table on the web page. So we have the equilibrated, air dried. So I'm thinking, all right, these are different types of bulk density. This is my current thinking now, and there's a unit, of course. Next slide, please. So I thought, all right, now, how do I link them up, right? So if I sort of reorganize them so they fit on the page. Apologies for the small text. But now how might they be linked up? So next slide, please, Mark. I thought, well, it seems sort of obvious to me that the bulk density of the fine material is then seems like it would be either a union or intersection of the fine earth concept and the notion of it being equilibrated. Okay. Now, okay, so fair enough. If that's the way that is, I choose intersection of at this point. Next slide, please. Then that's got to hold. That should hold for all of them. It should be consistent. And so at this point, I'm thinking, all right, well, I can squint and at least see this. I'm not sure. Like I said, I'm not a soil scientist, so I wasn't sure how valid this was. But I thought, all right, it at least looks reasonable. And so I'll have a look at the next database. Next slide, please. Which was SOTA, and I went digging in through their spelunking through their metadata, which is all online. So that wasn't meant to be a complaint. So I was looking through this table, which is massive, and I found bulk density. So I thought, all right, next slide, please, Mark. I thought, well, where does this fit? Where does this fit in? Now, I didn't notice any notion of method, right? And so I think a little takeaway there, you'll see next to bulk density, you see RDF property of, and I was treating those as properties where I think that, and I think they're methods, so that's obviously a discussion point. But I didn't see that in the metadata, so I didn't know how to decouple them. So I linked them in, just again, I color coded them and added the sort of Mach-E namespace bit so we could keep track of what was what. But I linked them into where I thought they would fit respectively, which is just either a whole soil sample or a fine earth sample, okay? And then I did the same thing for, if you go to the next slide, please, Mark, the ISRAD, which I have no experience with. So I was just having a look at what was available, and obviously then found the bulk density values, which apparently is a layer. I'm assuming that means GIS layer or similar. Oh, no, okay, well, we'll come back to that. You can square me up. Oh, soil, okay, fair enough. Right, yeah, that does make more sense. Okay, so then next slide, please. And so looking through there, I just grabbed the definition. So those are in purple now. The ISRAD layers, or the ISRAD values are in purple. And based on their definitions, I thought that they sort of linked in here. Now, if you have a closer look at the definition, they also mention roots, which weren't in either of the other two, at least not that I found, okay, in either of the other two. So this may be a little bit off as well. But this is sort of just generally speaking, sort of how I was thinking about aligning certain concepts. I also want to point out that if you look under bulk density, I just tried to capture the units, some of the units that were used. And I wasn't sure, well, we have equivalent units. I wasn't sure what's in some of the other units of measure ontologies. So is there an equivalent class, for example, in QUDT, so we don't have to recreate the wheel? We can just bring in something that's already that's already well defined. And I didn't notice anything, but there's actually been a lot of changes to QDT in like the last week, so I might need to check again. But anyway, that's that kind of idea. So the notion of what kinds of things are useful to the community, and then how do we pick them apart and stitch them together in RDF or OWL in sort of that ontological framework or language, and then what components are we going to need to pick apart versus what can we reuse, right? What's suitable for reuse, which is kind of an open question. Again, this was just me sort of thinking about how I might do it if I were on my own, right, without all of your help or all of us working together.
Brandon,
And again, this air dried versus field moisture and oven dried, I do think that those are I would if I were to go back, I would model those as methods and make bulk density similar with it's called a constructor where I used intersection of, and I would pull some things together to create the bulk density class. Again, Brandon, this is sort of up for yeah. Sorry, Simon.
I did drop a link to the QDT definition of mass density into the chat earlier.
Ah, excellent. Okay. I was just looking for units, so thanks for that. This was all. I would also like to mention it was also done quite quick, so don't take this as any sort of deep, well thought out thing. As you can probably tell, it's not. I was sort of, like I said, wanting to make a contribution and thought I'd whack something together. And Mark thought it'd be a good idea to run it by you guys. So yeah. Next slide. Go ahead, Mark. That's all I have.
Okay, great. Yeah, thanks, Brandon.
Yep,
that was awesome. And like you said, you put that together, pretty fast. It would be something that with the soil experts would be working with knowledge modelers like Brandon or Simon or myself, and we would iterate on that model and tune it so that it really served the needs of the research community. So this isn't just a sterile academic exercise. The next steps, I think that soil bulk density, Dave has gone pretty far down the road in collating a lot of that stuff, and he's got a good framework. We then need to translate that from spreadsheets and documents into an ontology. Also, we want to at the same time be sure that we're documenting the characteristics and the access to the databases that have those measurements, because ideally that's what we're going to use the ontology for, is to find data sets or to annotate our data sets to the ontology so that other people and as well as ourselves can understand them better. We can then start to think about expanding the set of measurements that we go through a very similar exercise with, whether it's KSAT or soil organic carbon, etc. And there were several that people mentioned on prior telecons. At this point, I think we want to really start thinking about building out an RDF OWL-based ontology. We would be thinking, the knowledge modelers would be thinking about design patterns and whether there are, terms that we can reuse. I think Megan at the last meeting was showing some really nice vocabularies that had been developed in Australia. ENVO, as I showed here, has some good soil typologies. So we kind of don't want to just start off and reinvent. We do our homework to try to reuse. And that's that contribute to existing ontologies. There's also this notion of governance, like, well, who gets to say, what's a good definition and what's not? And that's what I think this ESIP cluster actually, with Kathy and the co-leaders can, use ESIP as an organizational governance factor, and where it's an open and collaborative effort to develop this. So we're not under any kind of specific administrative strictures. It's a very open science type of an effort. And so I think we actually have wow, we did perfect. Some time for questions. Can I stop sharing my screen here?
This is Doug Wysocki. I don't have a question, but I'm going to make a couple of comments. Bulk density, and I take a little exception with some of the definitions. The common practice is to measure the mass after oven drying. Okay. but the volume is measured at, it can be, depending on the technique, it's generally measured in the field. So that soil contains some moisture. So there's a moisture content and unstated moisture content. So the volume can be measured at different moisture states, and the volume of a soil varies with the moisture state.
I was wondering if it might make sense to break that out into two composite
Right.
methods or measurements that you then aggregate to bulk density.
So
But I know that
I'm sorry, go ahead.
a lot of the data sets that I work with don't have that documentation. So while that's a good point, I think a lot of the data out there might not be able to speak to that, at least that's collected outside of NRCS or some of the national soil surveys.
And with the exception of, and I'm not familiar with the technique, but when that says air dry, I think what that means is that the weight was measured air dry rather than oven drying, which would be, there's value in that, but that would be, I guess, an exception. Most bulk density measurements are oven dry weight. The other point I would make is that when we talk about whole soil, that can, of course, include coarse fragments. But when you upscale to a factor like, let's say, carbon, if you want to do aerial measures of carbon, all other measures of soil, such as CEC and carbon, are all on the 2 millimeter basis. So,
Doug, so I hear your, and I trust your expertise. I would say if you can express some of these exceptions or qualifications the way that you are, you can also model and capture them.
right.
And so that's really, I think, one of the advantages of this semantic approach is you can make those sorts of assumptions, or things that are being overlooked that you didn't take into account. You can make them clearer by specifying them in this formal way in an ontology. So it's really not, it's not straitjacketing you. It's actually allowing you to really enrich your metadata in a way with some additional features that actually come from specifying them in a formal knowledge language.
And I would agree with your statement. And I can see, or my expertise lies in the soils. When you say you can do that, now I can't deal with the ontologies. I don't have that expertise. So it's, the fact to communicate these and get the expertise together that can do the things that need to be done. So it involves everyone that's on this.
Absolutely.
And it might also be useful to capture the sort of the most detailed understanding of these measurements that we can, so that we can give experimentalists a tool to report their methods accurately in their data annotation. And if we can get that annotated, we can then develop those tool sets for that easy data reporting. So that part I find really exciting too.
Yeah, one of the other things, and that's absolutely right, Kathy, but one of the other advantages is with this kind of hierarchical approach like Dave was showing, you don't have to go into excruciating detail. You can if you want, and that's super, and that will also be nicely structured as well. But if you only have the time or the willingness to do it at a very coarse grain, there's a saying in the semantics world, a little semantics goes a long way. So just telling me that these cryptically named columns in your spreadsheet are bulk density measurements, that may be better than nothing. So that's another one. You can always just go very coarse, but you can also go very, very fine grain.
Yeah, to flip the script slightly, it's describing something to a level that you can disambiguate between the two and no more, right? So don't go any further, which a lot of times leads to sort of shallow semantic models, but it gets you a lot further than you would have if you would have spent all the time and money into building the deep, dark thing. Anyway, just a thought.
Well, I think that we might have some folks who have access to databases that do leverage the deep dark things, because the RCS and the Cicero data all seem to be highly detailed methods documentation, which is fantastic.
Yeah, and again, the benefit here is not for your kind of daily use of the databases that you're deeply familiar with. It's when, you know, you're trying to find additional data, complementary data, you're broadening your scale, you're synthesizing. That's when all of a sudden you encounter this whole problem. We call it the 80-20 problem, right? You spend 80% of your time trying to find and wrangle the data, and then you really only have 20% left to, you know, tune your analyses and gain insight. Any other questions?
Megan has an excellent observation in the chat.
Yeah, about
Give me this
whether...
time. Can
we got you.
hear me? Yeah, I'm not familiar at all with the suite ontologies. It was just from the that working group, that session last night. I have challenges deciding, you know, often the concepts, the vocabs out there are poorly described or grouped or whatever, you know, the proper language is there. So I can't tell whether I'm looking for an observed property. I can't tell whether it's a process or an observed property or a procedure or a sampling method. You often just can't tell. And there was a slide that was put up that said that the suite ontology groups things by what looked to be perhaps useful things to use, cluster things by, nest things under, whatever your language is there. So I wondered what people's thinking and experience was there, perhaps.
Yeah,
the need to put these
posted.
concepts into context to make them, you know, to help us be able to apply them to our data in a correct way.
Simon posted an answer to you in chat, Megan, and I agree with you. I mean, what you're talking about is where when you get into the mid and upper levels of ontologies, things can get kind of murky and there's disagreement. So, you know, there's something called the basic foundation ontology or BFO ontology. There's one called the SIO, which stands for, I think, Science Integrated Ontology. I can't remember. There are several of the Dolce. There are several of them where you're talking about processes and entities and very, very abstract ways of looking at the world. You know, whereas for me, I mean, everything is a process. But I recognize the benefit of identifying entities like you and me, you know, even though we're processes. So, you know, you do what they call commit to an ontology. And Simon posted a reference to SOSA, which in the context of measurements is extremely useful. When somebody is taking a measurement, there's a process involved in taking a measurement, but then there's the result of that measurement. And that's what O&M addresses it very well. I have one called OBOE, which is another observations and measurements that also talks about methods and protocols involved in the taking of a measurement. So, again, a little semantics goes a long way. So don't get hung up in that kind of the clouds of mid and upper ontologies is what I would say.
Yeah.
And by the way, Simon is an expert on these things, so you should take him out for a pint or two if you want to really.
Oh yeah. No, Simon's quite useful. We're working with one of his old colleagues, Bruce Simmons, on applying these vocabs to O&M. So it's just navigating the jungle of vocabs out there. Yeah. Any way you can help us navigate that jungle.
We started out wrestling in those mid and upper levels for quite a while with different conceptualization, where you're sort of like reading, you know, Nietzsche and Wittgenstein and all sort, you know, Bertrand Russell. It's like you go nuts. Okay, so then we decided let's go right down to the data, which is what scientists are most interested in, and it's sort of most concrete. And that's where I think these observations and measurements ontologies are very helpful. But really, it's like, what is that feature of interest? What is that observable property? You know, the feature of interest was the soil. The observable property was its bulk density or soil sample. I know Simon's going to jump in there and go, it's a sample of soil. But, you know, but a little semantics goes a long way in any case.
So I would love to move forward with trying to work out some type of ontological understanding and how it relates to the data sets that at least my group's interested in harmonizing. So what is our next steps, seeing that we're at the top of the hour?
Well, I think that we should articulate, keep moving forward with the bulk density, because we'll develop nice design patterns based on that. And Brandon has taken a courageous first whack at that. And I think the danger is getting lost down in the weeds of too much methodological nuance. We got to remember a little semantics goes a long way. Being able to say that these two data sets on several continents have soil bulk density measurements, maybe that they are oven dried, maybe that they are, you know, 0.33 kbar or whatever you call them. Heck, that gets you, you know, try to do that now. Try to find the data sets around the world that your social networks haven't informed you about that have that information. This would immediately enable that through the semantic web.
Mm-hmm. Mm-hmm. All right.
Just got a scan of the relevant 4 or 5 pages from CSIRO's lab methods book, which describes the Australian definition of bulk density. Linda Gregory's just scanned it for me and sent it me by email. Who should I forward that to? You, David?
Me too. Because David was going to do that, but that it's behind a paywall, right, David? Wasn't it behind?
That's why I got Linda to scan it. Okay.
Well, I mean,
Mark, do we just pop our use cases in the Google? We popped ours in. We don't have methodological stuff particularly, but high level feature business. Do you just pop them in that Google? Pop it in the Google folder.
Yeah. Okay.
So I think both strands are interesting, right? So the one on the one side, taking, for example, what's in, let's say, the Brown book, since that was the last thing we were talking about, and really what the text is in there, and really trying to model that completely, right? Like a thorough deep dive into that specific method, right? And then sort of juxtapose that with what maybe Mark was more alluding to, which is sort of, well, what can we connect across many of the databases, right? So what's the sort of, if you like, surface level semantics, sorry, and then that deeper model, and see where the touch points are. That's just a personal thing. That's interesting to me. How many databases are we talking about that are in your review?
We've got about 12.
Wait. Oh, sorry, I was trying to look at the GitHub page while I was talking. Apologies.
No problem. I think we've got about 12. Not all of them are on the GitHub page.
Okay.
Some of them are still in progress, but we've got about a dozen or so, ranging in size from relatively small to super large. So,
Okay.
and you touched on on a few of them,
Okay.
ISRAD, SOCDRAR, or SOTA. But I think it would also it's really interesting to look at the soil survey data sets, because those are probably the most detailed that you're going to get with the procedures. And then I think it'd also be really interesting to look at the researcher side of the house, where you're going to get probably less specific documentation, or at least less uniform documentation. So a lot of the data sets that I've seen, fine earth or whole, and dry or field moist, are sort of the two distinguishers that I see most of the time. All right. So with that, we are, I think, a little over time. Does Dylan or Andrew or David, do any of you want to give a sort of a pitch for 2 weeks from now, what you guys are going to be talking about?
Hey, this is Andrew. Can you hear me?
Yes.
Yes.
Hi. We sent out a kind of a preliminary title for our presentation on the 16th, which is going to be sort of looking at unifying concepts and, central concepts and unifying themes. I think that's what I called it, of the NCSS databases. And so we're going to really kind of talk about some of the higher level structures that are necessary for understanding our products and relating some of these individual point observations of soil properties to space. And so that's going to, bring in aspects of Surgo, which is our geographic data set, as well as, our very sort of robust lab data, as well as some information about the point data that is collected by our field soil scientists who are developing our map products. So I guess that's kind of a high level overview.
Great, looking forward to that. So we'll also start an email thread on next steps to try to keep the momentum on this bulk density conversation going.
There's 4 pages JPEGs, I'm afraid, sitting in the Google Drive folder now.
Excellent. All right. I will see everyone in 2 weeks. Thanks for a great discussion, folks.
Thanks.
Thanks for the discussion.
Thank you.
Thank you.